All right, looks like we are live. Everybody, I want to welcome you to Standing for Truth. Thank you for being here. We have an epic show for you guys. I am your host, Donnie, and it is a privilege to have Stef Heerema here back with us. Steph, thank you so much for being here.
Yeah, thank you, Donnie. I look forward to it.
Me as well. Me as well. This is exciting. And for the audience sake, the title of today's presentation is Overturning the System, Igneous Origin of the Castile. And this will also be a response to Kevin Hankey's latest arguments put forth on a video titled The Green River Formation. Now, what we're going to be doing, though, is we're going to be having a technical presentation from Stef, and then we're going to get you guys in the audience involved. So please make sure you're tagging me with your questions. We'll try and do our best to keep the questions on topic and related to the presentation. So that being said, we also have George Bond in the house. George, good to see you. Any words of introduction from you, George?
Yeah, look, I don't know much about the Castile Formation, but hopefully I can add something to it. I'm pretty sure Steph will agree that, there's millimeter thick laminae apparently traceable over about 110 kilometers. And the Castile Formation is in West Texas, I think, Delaware or near Delaware somewhere. And keep in mind, this kind of sedimentation has never been observed. So I'll be very interested to see what Steph's presentation entails. Because anytime you don't know something and you learn something new, it's always a good thing. So over to you, Steph.
All right. Thanks. It's something new indeed.
Amen. Well said, George. Again, Steph, thanks for being here. To the audience, we've already got support coming in. Jamie Russell, I appreciate the super chat. And Doki Doki SFT fan club, thank you for the super sticker. So again, tag me with your questions at Standing for Truth or even at George Bond. He'll be in the chat. We'll be saving questions together. If you're new to this channel, we just hit the 6,000 subscriber mark. So I want to thank all our supporters and subscribers for making that possible. If you're not yet subscribed, please hit that subscribe button. Make sure you hit that like button as well, and share around this content because the truth is important. So that being said, we're going to hand it over to you, Steph. The floor is yours. If you had any words of introduction, feel free to do so, and we'll also get right into your presentation.
All right. Yeah, well, it is what George says. It has never been observed how this is formed, and well, everybody says this. The Castile is formed by water, from water, but I will overturn that system. I think, well, I can prove that it has an igneous origin, the layered Castile. So let's go for it. Well, the background, as Donnie introduced already, the background of this rebuttal, Dr. Henke, he thought he had a strong case to disprove young Earth creationists in July. However, I've reviewed him also in the end of July, and then this led to some reactions by student Wilford on behalf of Henke and Henke himself in August. But today is the time to put their arguments to the test. I must say it is a pity that they do not simply believe the word of Christ the way their ancestors did. If they don't believe Jesus, how would they ever accept my scientific analysis? But for their sake, I will do my best, as evolutionists will not enter the New Jerusalem. Okay, well, this is a picture of the Castile, and note those cracks in there, in the anhydrite layers. I will come back on that later. Now, despite of 50,000 exploration plus hundreds of thousands of development wells, in spite of all this research, few areas have more unresolved geological controversies than the Permian Reef complex. That was written by Scholle and many others in 2007. And it was student Wilford who appointed me to this publication, so I thank him for this. Well, evolution theory does not provide a solid explanation for the Castile, nor for the wider region. And only one explanation model should remain. Therefore, I will demonstrate the following. Salt magma explains the features of the Castile, plus all other salt in the wide area. The salt magma model, flood model, indeed is overturning the system. Henke's model, however, conflicts with facts, and he's very wrong with looking into the Castile in isolation, because that's what he is doing. In the Castile, there is an abundant amount of salt in the wide area. The Castile is part of the Delaware Basin. And there is an abundant amount of salt in the wide area. It's all been neglected by Henke. But we see the wide sands, the Midland Basin, the Palo-Duro Basin, the Valverde Basin, and it's all part of the Permian salt basin. Well, I've shared this before in my other presentation, but the Castile is just a feature at the end, at the south edge of the Permian salt basin. Now, crystallizing in layers, like in the Castile and in other salt giants, is normal in layered igneous intrusions. So, by example, the Zechstein salt is a core from about 3,000 meters, and you see it shows the layering in it. And that's common in salt layers. Now, we see the same in the same layering in an igneous intrusion here. This is not a salt, but we see the same layering. Now, note that this is sodium chloride and then calcium sulfate. Note that the calcium sulfate and the sodium chloride layers are not chemically bounded to each other. So you can see they have been easily broken. So there is no chemical bounding to these layers. And I will come back on this later when I address the secondary seep-in of oil. Now, flow bending is a geological term to describe bends or layers that can sometimes be seen in rock that formed from magma. And here we see the flow bended rhyolite, and that's not a salt, but you see the flow bending. And in the Cordona salt outcrop, we see the same, but we see also a flow bending. And here in the Netherlands, there is the Zechstein salt again, and also there we see that there is an annual layering. Well, I don't believe it's an annual layering, but that's what geologists, secular geologists have to tell us. This is an annual layer, and this is an annual layer, and what is this then? So how is Henke going to explain the folding of several annual layers packed in between other annual layers? So I see this is clearly evidence that the layers solidified from a salt magma. Now, how to explain layering in rocks from an igneous origin? Now, fractional crystallization or crystal fractionation is one of the most important geochemical and physical processes within crust and mantle. And and Henky doesn't know about that. And then cumulate rocks are igneous rocks formed by the accumulation of crystals from a magma, either by settling or floating. Cumulate rocks are named according to their texture. Cumulate texture is diagnostic of the conditions of formation in this group of igneous rocks. Cumulates can be deposited on top of other older cumulates of different composition and color, typically giving the cumulate rock a layer of or banded appearance. So the Castile is a cumulate rock from a salt magma by settling. And the overlying salado is a crystallized residual magma. And here we see them. So this is the Castile. That is a cumulate rock, a layered cumulate rock, and there's the overlying salado, which is it contains loads of sodium chloride. The Castile is mostly anhydrite. The salado is mostly sodium chloride, and then there is a cap rock containing all kinds of salt. Now, what we see in here, this is just a model. I'm sketching a model here for you, not to scale. It's just drawing a picture. And so when we have a continental crust and a salt magma chamber underneath, then from that, now everything started, of course, with the flood. The flood was delivering flood deposits. And then suddenly the salt magma chamber erupted salt. And that is a parental salt magma, and of course surrounded by steam and supercritical water. And so here is formed a dike or a salt weld. And from this parental salt magma, from there was formed the layered cumulate rock. So with the expansion and when the pressure released, then anhydrite started to crystallize out of this magma, out of this parental salt magma. And the anhydrite was delivered in a cumulate rock, the Castile. And then the residual magma crystallized on top of the anhydrite. Anhydrite is much more dense than the other salts, than the salt magma. And then on top, the cap rock was formed, and then on top, the other overlying flood deposits were deposited on there. They are not drawn in this picture. So what else do I have to say here? So the heat of the molten salt caused supercritical water to form in the wet flood mud. Flowing upward, the pressure decreased and the water expanded into steam. So the Capitan limestone is a carbonate mud layer that was displaced by the expanding steam and by the weight of the salt magma. So there was expanding supercritical water expanding into steam, and this expansion and the weight of the magma and the weight of the anhydrite, all the mud underneath was pushed aside, forming a caldera. Now, this expanding steam didn't cause classification as temperature and pressure both were too low to let it happen. And anhydrite is more dense than the residual magma and accumulates below. Well, I said that already. So this is only a nice symmetric model. However, reality is different, as the central basin platform stood in the way. And this is reality. And where to start? This is the Castile, what you see in here. This is a cross-section over the Delaware Basin, the Central Basin platform, the Midland Basin, and the Eastern Shelf. Now, the anhydrite, that is what is found in the Castile. So this is the Castile. And on top of that, you see the Rhyolite. That's the green one. And these are all the flood deposits, the flood sediments underneath. And here you see the fold in which the salt magma welled upwards. And now, as I said, the anhydrite had a greater density than the residual magma and accumulated underneath. So the magma came up through the fold and accumulated at a lower place, and the magma was this because of its density, it was not able to flow over the central basin. The central basin platform was already in place, so the more dense anhydrite that accumulates in the magma stayed below there. But the magma continued and overflowed. The residual magma, however, flooded the platform, delivering Rhyolite into the Midland Basin. Yeah. Now we come. This has been ignored by Henke because he simply said, well, the Castile is anhydrite, so there is no ionic liquid with many ions in it. But yes, there is. However, the anhydrite was just accumulate rock out of it. So salt formations crystallized out of molten ionic liquids. And sadly, geologists cannot notice it as they are not educated about ionic liquids, as I told before in my earlier presentation. And this ionic liquid is a salt magma, a dry, hot, molten mixture of ions. And well, here all these ions are there, and there are more to involved things so, however in smaller quantities. Now this formed the flow-banded Castile with vibes of anhydrite, calcite and some halite. This formed in the overlying salado layers of halite, anhydrite, calcite, dolomite, magnesium chloride, sulfide, etc. And also the Rustler cap rock, which is mostly anhydrite, halite and calcite. However, the flood delivered also chalk, clay and sand in here. Now, where are these feeder dikes situated? Well, I think the feeder dike is in the late Pennsylvania and early Permian fault zones and compressional structures. And I lent these from Scholle. He drew a figure. He had a figure in his work with all these faults drawn in, so I took them over. Scholle referred to several faults, and I drew them in this map. Each of them could be the feeder dike wherein the salt magma welded up. However, the best situated candidate is the north-south fault. This one, the north-south fault, east of the basin of the Delaware basin, and the border with the central basin platform. The central basin platform is here at the east side. Now, similarity, I've shown this before, similarity between salt welds and igneous dikes are very well known. And in 2018, Willis published that welds may form in igneous environments as melt invades and then is removed, often exhibiting remarkable similarity to salt systems, which confirms my ideas that this is an igneous structure. Now also the Gulf of Mexico provides an example of feeder dikes, and you see here that there is lots of igneous salt, and these are all sediments, flood sediments, and this igneous salt is delivered in diapirs, and we can easily see that they came out of faults hidden deep in the earth crust. Now, Why does molten salt produce so much steam in contact with water? More than any other magma? Because that's a point that was brought in by Henky. How is that possible? How will you have so much steam? Because that's part of my model. Well, because molten salt can transfer loads of heat into the steam, where molten basalt cannot. As simple as that. Basalt has a low thermal conductivity, and you can see here that the basalt has a low thermal conductivity. And in molten state, it's also slow flowing. In molten state, you see it has a very high viscosity, so it's not fast, it's very slow flowing. Where sodium chloride is the opposite. It has a high thermal conductivity, and it is the viscosity is very low, equal to water. It can run like water. Now, I don't know the figures for molten calcium carbonate, molten anhydrite, and molten sulfide. However, I've run a test with anhydrite and halide, and they are readily to flow as well in a mixture. I don't know what happens when all these things are together. However, we have the example of the Oldonio Lenge, and there it is a very readily fast-flowing magma what comes out of this volcan. So let me see, did I address all my points? So where the salt solidifies in contact with the cooling water, it has a high thermal conductivity. Also, the salt magma will quickly circulate and transport new heat to cold spots. Therefore, molten salt can transfer its heat capacity to water very quickly. And the water turns into steam, which results in an enormous increase in volume. And given the huge amount of molten salt, we talk about, in the Castile and the surroundings, it's a salt giant. So I didn't calculate it, but I wouldn't be surprised if it's 100,000 cubic kilometers of molten salt involved in here. So that's huge. And the steam production continues for some time in that situation, causing a lot of flat mud to move laterally from underneath the salt. Now, they say there is no evidence of contact metamorphism. But why would contact metamorphism form between steam and floodwater, which was holding sediments? And I will go deeper into that. Now, the water cools the sediments. Then the flood water is there and it cools the sediments, preventing high temperature contact metamorphism. And so what can I see? Where shall I start? We see here the muddy floodwater with sediments, and these sediments are settling, going downward. That means that the water is available and there is a water layer that is hot. Let's say it's 100 degrees. Then on top of that, it's heated up to steam temperature. Let's say it's 300 degrees Celsius. There is high pressure available. And then we see the solidified Castile, and it's floating on this steam pressure. And underneath the Castile, we see that the steam will float aside, with high speed, and it will bring all the calcium carbonate, all the flood sediments, it will bring it aside. And then on top, we see the molten salt magma, with a temperature of about 500 degrees Celsius, like we see in the Oldonio Langer Vulcan. So we see a huge difference distance between the sediments on 20 degrees and the molten salt magma at 500 degrees. So all the water in between cools the sediments, preventing high temperature contact metamorphism. Now, this is something about the water and about the critical point. Water, we all know that water can be liquid, and when you turn it into gas, you have to add some energy. And that is a change of phase, and you need to add energy in there. And however, there is a critical point that the temperature and the pressure are that high that there is no condition change anymore. There is no phase. You can't jump from liquid into gas here anymore. It's all, that's critical water. And my impression from the Castile, as it's quite high in the geological record, is that the pressure was below the critical point, and that this is the curve that the water, the flood water, was. That this represents the temperature of the steam layer here, but maybe it was above, and then, but I think that the pressure was, this is enough to tilt the Castile. With this pressure, you can tilt the Castile and the molten salt magma on top of it. So this will be enough. So the expanding steam caused a caldera to form. And now the caldera is misinterpreted as a reef by geologists. But it is a caldera and not a reef. Now note that there is a lot of evaporation going on here. So the muddy flood, well, the flood delivered water, and the water delivers to the steam, but that removes preferentially the lighter isotopes. You have water with high isotopes, high density isotopes, and you have dense and lighter isotopes. Now, when you have evaporation process in place, then the lighter isotopes will go into the steam first, and I will come back on that later. Now, Henke claims that glacification should confirm an igneous origin. However, the steam that bulldozed the flood mud into the walls of the caldera had a low temperature. And well, but at the other end, there are abundant crystals in the area. So what about Crystal Cave, L'Aquila Cave? So, well, maybe there was even glacification. Anyway, it's not very good point from him. And in my search, by the way, I found that the area was long ago mined for saltpeter, which again confirms an English origin. Now he says that oil within the Castile, that contradicts with an English origin, as it is, because if you have an English origin, then you have a high temperature, and above 200 degrees Celsius, you can understand that if there is oil in this situation, it will break up into methane gas. And well, that's a correct point. However, the oil wasn't there. The oil came there in a secondary system. So at first the Castile solidified from a magma, and then later the oil came in. And I can quite prove that because we have this reference of Scholle again. The largely evaporitic Ochoan rocks have accounted for less than 0.01% of the Permian. By contrast, the Guadalupian has accounted for 67% of all Permian oil. So what we see here is there was not very much oil in the Castile. There's only 0.01% of all the oil in the region is found in the Castile. And that's because the Ochoan Castile is just a reservoir rock for oil that seeps up from the underlying Guadalupian rock. Yeah, so the existence of oil shows only the temperature didn't exceed 200 degrees Celsius after the oil arrived, but the oil arrived later in the process. And so the oil seeped up from the underlying Guadalupian rock where oil was available. And this is another, here you see how the oil was there, formed in the flood deposits, by the heat of the salt, which is in here. Here is the salt, and here the salt has been solidified in there. It transferred its heat into the sediments, and the sediment, all the organics in the sediments became oil. And then later in the process, this oil was pushed up because oil travels in rocks. It is less dense than water, so it will float upwards. Slowly, it will flow upwards. Now, you can see here that the vertical tectonic provided the conduit for the salt magma. Now, when and why did this 0.0 0.01% of oil seep into the impermeable Castile? Because the Castile was impermeable. These layers, you can't pass a layer of anhydrite. It's a closed layer. Now, the oil formed in the 7 kilometer thick layer of sediments underneath the Castile by the heat of the igneous salt, and the Castile didn't contain oil after solidification. And note that the anhydrite calcite valves in the Castile are not ductile, like the impermeable overlying Salado halide layers. Halide is slightly ductile, anhydrite calcite valves are not ductile. Now, tectonic tilting and uplift, late flood, caused many fractures in the Castile. I showed them you earlier. Every fracture provides a vacuum empty space. A vacuum empty space. Do you understand that? Because there is nothing. There is nothing. You have a rock, it breaks, then there is an empty space. It's a pure vacuum. So when these faults formed, they sucked in fluids from below because there was an overpressure underneath, and here is a vacuum. Well, they sucked in these fluids from below, and what are these fluids? Well, there is oil and there's water. And now the valves, I showed you already this picture, the valves are not chemically bonded. So the calcium sulfate is not bonded to the sodium chloride, and it's not chemically bonded to the calcium carbonate. Therefore, the oil and the water penetrated the Castile completely. That's oil. The oil is very good in penetrating narrow cracks, especially when it's a bit hot. So that's where the oil seeped into the Castile. Now, geologists also analyze water out of the Castile. that has been sucked in after solidification. And obviously, that brings them to incorrect conclusions. Henky had many examples for that. Well, however, it is immersed water with a history in the Great Deep, where after abundant steam production removed preferentially the lighter isotopes. And then later, this water has traveled from underlying flood sediments into the cracks of the Castile. The water did exchange ions all the way and is analyzed thousands of years later, showing what? Whatever is found in that water, I wouldn't dare to draw conclusions from it. And let me cite Roger Eckhart on this subject. Most people are aware that rainfall, as it seeps into the earth, becomes laden with dissolved material or solutes. What they may not realize as fully is that the composition of the solutes can change drastically as the water passes from one geochemical environment to another, causing significant relocation of particular elements in relatively short geologic times. So I think it is a scandal that geologists waste public money for these costly tests. Now, decomposition is brought in. Decomposition, calcium carbonate to calcium oxide and carbon dioxide, is, however, prevented by the low temperature and by the high pressure. Now, Henky had an example of exceptional high pressures and whatever. I don't know what he wants to say with this. We have examples. We know for sure that decomposition temperature for calcium carbonate is 825 degrees Celsius, where we have a process. I've presented you a process, a magma, with a temperature of only 500 degrees Celsius. So why would we see a chemical decomposition of calcium carbonate, which has a decomposition temperature at 825, and we are way underneath it with 500 degrees Celsius. And this is at 1 bar, at 1 atmosphere. However, if you compress it at a higher pressure, and that's what we do, we have a pressure of more than 100 bar in this calcium carbonate. So it's just not right to say that decomposition proves of that there is the absence of decomposition proves that this is not igneous. That's not correct. And as a reference, decarbonization doesn't happen within the salt magma of the Oldonio Lengue as well. Now, the Castile is part of the Permian Basins salt giant. Yeah, the Castile is not, you shouldn't look in isolation at the Castile. You should look the wider picture. You have to widen your picture. It's part of the Permian the Permian Basin salt giant. So Henky shouldn't ignore these references. Evaporation alone cannot explain salt deposits several kilometers thick in salt giants. In 2019 by De Buer. And the other one. Salt structures have not been produced by cold flow of rock salt, but by hot flow of salt lava, as published in 2021, this very year. And he ignored these references I brought in my presentation, and he's just not right. The Permian Basin is a salt giant, and the Castile is part of it. So you have to deal with these references. He has to take them serious. Now, also, he ignores my own publication of 2018, Salt, Magma, and Sediments Interfingered. Now, and Henki's reference to an unpublished paper by a geology student. My goodness. I don't know why he brings that in, but it's moreover, he doesn't address the Castile in that publication as well. So it's just irrelevant. So, okay then. I have presented a well-founded and solid explanatory model that explains all the observations around the Castile within the flood. Now, evolutionists say the same about their model. So, is everybody free to choose the explanatory model that fits their philosophy of life? Now, let us test Henki's model first. Well, I will not repeat my earlier presentation, as those arguments all still stand, but I will zoom in on anhydrite only. The Castile is mostly anhydrite, which is dehydrated gypsum, calcium sulfate with crystal water in it. It's a metastable crystal. However, it's not easy to dehydrate gypsum crystals because it's metastable. And we have the examples in our houses. Plasterboard is made from gypsum. It's used in building partly because of its flame retardant effect. Because plasterboard is containing loads of water, and it's like you have a vertical wall of water. That's what plasterboard is. So it's flame retardant. And gypsum is another example. Gypsum is a stable crystal in desert environments. We can find them there. So even in the desert, gypsum is stable. It doesn't dehydrate into anhydrite. Sorry, here. Now, Henki refers to Kirkland, and Kirkland in turn misrepresents lab results. So Henki thought he had a solid case in this, but he has not. Kirkland published in 2000 in a brine derived from seawater in which sodium chloride is saturated, gypsum dehydrates to anhydrite at temperatures over 18 degrees Celsius. Whoa! Well, the gypsum in my house, in my plasterboard, is still gypsum. It hasn't changed into anhydrite. But here it's a scientific publication. Gypsum dehydrates to anhydrite at temperatures over 18 degrees Celsius. While settling through hundreds of meters of warm, over the 18 degrees, nearly sodium chloride saturated Castile brine. Now he has two references for this, Hardy 1967 and also in 1979, and we will check them both. Starting with Hardy. Hardy wrote in 1967, an abundant amount of anhydrite must be, an abundant amount of anhydrite must be explained. However, what does Hardy conclude? Hardy concludes, the scarcity of anhydrite in modern evaporite deposits is predicted by the present results. So Hardy is not really an effective source to underpin the Castile, the formation of the Castile from water. Now, and note this, at 1 atmosphere pressure. However, here we read, while settling through hundreds of meters of nearly sodium chloride saturated Castile brine, hundreds of meters of salt water. So that represents at least 25 bars, and maybe much more. Depends on how many hundreds of meters are involved in here. But we have at least 25 bar that causes this pressure. And that complicates dewatering even more, as dewatering causes a volume increase of 10%. And remember, transforming gypsum into anhydrite plus water causes a volume increase of 10%. So you have 1 mole gypsum and it will form 1 mole calcium sulfate and 2 mole water. And this together is 10%, is a 10% larger volume than the original. This is a more efficient crystal. Now, plasterboard and desert roses retain their crystal water in the desert. But these scientists believe that they release their crystal water under water layers hundreds of meters deep. But there, the pressure is higher, and it is also colder, and it's wetter. All these 3 factors will actually hinder the conversion to anhydrite. So, if it not happens in the desert, then it will certainly not happen underneath hundreds of meters of water. So where are these lab tests confirming that over 25 bar and at low temperature at 18 degrees Celsius, gypsum dewaters into anhydrite? Now we go to his other source, that's Holzer, 1979, and he referred to figure 13. Now this is the figure 13 that was referred to. But note, this figure is at atmospheric conditions. At higher pressures, it's even more impossible to produce anhydrite, but okay. So, this figure, what can we read from here? This is the temperature. Temperature 20 degrees, 40 degrees, 60 degrees, 80 degrees Celsius. We have seawater. What comes into a basin where it's going to be evaporated by the heat of the sun. So the result is a brine, a salty brine. A brine contains more salt than the original seawater. And this is the salinity and the evaporation ratio, and this means at this point, this means that here 50% of the original seawater has been evaporated. And at this position, 75% of the original water has been evaporated. And well, it's a bit complicated to read it here. It's 90% of all the water has been evaporated. So you see that the brine is getting a denser brine and more oversaturated. And however, the seawater comes in at a certain temperature and it starts to evaporate the seawater. So the curve that fresh seawater travels through first causes gypsum. There's no way around it. We form gypsum first, after which conversion to anhydrite becomes unattainable. Because if gypsum, here we see this in page 248 from this very reference. If gypsum is heated in the laboratory in the presence of water, the gypsum will continue to exist metastably up to temperature of nearly 93% and then transform to basanite. That's still not calcium, that's calcium sulfate. This is still not anhydrite. There is this basanite is still having some water in it. This is, by the way, the stuff that you can buy in the market when you have to do some construction in your house, when you want to make gypsum. This is what you buy in the market, and you put water in it, and then it transfers into gypsum. So, but we need, we see here that Holzer wrote down, although continued dehydration at high temperatures can yield anhydrite in the laboratory, it is nearly impossible to grow from solution. That's what is written in this very reference. It's nearly impossible to grow from solution. So anhydrite, to conversion to anhydrite here is nearly impossible. Now, also wrote, and this gypsum is not easy to dehydrate into anhydrite, and these are puzzling example of metastable relation. And I'm citing Holzer here. These are puzzling example of metastable relations. It's not as simple as Henke and Kirkland showed us. So, and note that Holzer effect falsifies his own figure 13. That's what is written here. So it's not as easy as that. Now, my advice to evolutionists is please take seriously the finding of primary igneous anhydrite. It's a recent finding and it's largely ignored. It's in 2008 presented in a publication. And take it serious. Please do so. Or if you really want to waste more time and money, if you really want to do so, to waste the money from taxpayers, then please prepare this lab test in desert conditions with seawater at one side of a permeable and the basin at the other side. And then you can see for yourself that the Castile cannot be formed in that water. Now, my recommendation will be that scientists, they have access to budgets, billions of dollars. They have access to these monies. And they have access to tooling, they have the expertise. Now, they should do tests with ionic liquids to get a better understanding. I've tried these tests myself. I don't have enough funding and I don't have the right tooling to do so. But these people, these scientists, they have them and they should use their resources to understand the ionic liquids, it's salt magmas. Now, I want to thank Kevin Henke and student Wilford for pushing me to come up with a stronger refutation of their work. It is, however, it's now time to overturn their system. Now, if they or anyone else wants my presentation for further research, then please send me an email and you can have it and use it therefore. Now, are there any questions? Then you're welcome to come with them. I hand it over to you, Donnie.
Thank you, Stef. Let me just remove the PowerPoint from the screen. Another fantastic presentation, Stef. A few people in the chat were saying, making a prediction that Kevin Henke will probably tap out after this one. Great job, great work. Very technical, very detailed, a lot of data, a lot of information. So clearly a lot of hard work was put into that, Stef. And I really appreciate it. God bless you, brother, for that.
Yeah, it was quite a search, I must say, to find these references because it's easy for Kirkland to make a reference to something in 1979, but how will I get access to it? So, right. But it worked out. Yeah,
you did a great job. You did a great job. This is a presentation I am going to have to watch 2 or 3 times just to get it all. It's very detailed. You addressed all of his points and arguments thoroughly, while from my observation, and you pointed this out in your presentation, Kevin seems to be ignoring and dodging a lot of the arguments that are problematic for his position. Jamie in the chat says he's going to watch again as well. Very technical. Very well done, Steph. Very well done. George, any thoughts, any points you wanted to make before we get into a few questions here?
Yeah, I'll second what Jamie said. I found it technical as well. I think that reflects in the fact that we didn't get a lot of questions for you, Steph. I have a similar sort of experience in terms of getting citations from people I have conversations with on the internet. I can't remember the exact example, but someone gave me a citation to a link on a website. I found it to be a blog, and to my amazement, the actual article was didn't have an author. All it had was 2 initials. So I said to the guy, "You have to be kidding me! You're providing this citation without the author's name as a credible piece of information." But Steph, I was actually interested in some of those photos that you showed of the halite and anhydrite bent in those shapes. I figured, how can that happen? Unless it was moist or warm and some kind of a vertical and horizontal displacement occurred, I can't imagine how that would happen over millions of years.
Yeah, I have the same feeling by that. It's only possible when you when it's solidified in that position from a magma. But how can it happen from when it's original being delivered in horizontal layers?
Yeah,
from water, and then somehow it's solidified in all that bended structures. I don't know. It's something for evolutionists.
To me, it just looks like those layers were fresh, moist, and something happened to them. Probably a combination of tectonic plate movements in the vertical and the horizontal sort of direction that caused it. And that's the only explanation I can sort of see that makes any sense to me. And that proves another piece of evidence for a young Earth. It couldn't happen over millions of years. Yeah.
Yeah. Yeah, I think you're right. However, I think we don't have enough research in the solidification process of ionic liquids, of a salt magma. And I think when we have more research on that, that we then will properly understand how exactly all this bending happens. Because we see flat layers, just horizontal layers flat on top, and then in between we see these strange bending. And I think it's something that has to do with the solidification process from the magma, and not in the first place with tectonics.
Yeah, there's a bit of sarcasm in this question. I think there's a bit of humor involved. It's from our one and only Doki. They ask a question that says, "Steph, how can you make these observation-based conclusions? Shouldn't you assume a deep time worldview first, then force fit the data?"
Yeah, that's what Kirkland and Henke and Wilford do. Indeed, they just force the data into it, but it doesn't make sense. It doesn't make sense at all.
Well, remember, they never question the bigger picture, right, Steph? They'll at times question some of the details within the bigger picture, but the bigger picture, that's their worldview, that's their paradigm, that's the position they are not going to question.
Yeah. They miss the helicopter view.
Yeah.
They are unable to do so.
So here's a question that comes in from Jamie Russell. Jamie, I appreciate your question. Any questions now, guys, in the chat that you have for Steph? I can put them up. I can put the questions up on screen as well. So keep tagging me, and we'll do just that. So Jamie asks, Steph, where do you get the most pushback and why?
Yeah, it is well everywhere. I must say, I have a pushback now from Henke and Wilford and well. From other secular geologists, but also from theistic evolutionists here in the Netherlands. But strange enough, I have also pushed back from young Earth creationists, because young Earth creationists have embraced the idea that the salt is formed from water, from hot water that was available with the floodwater. And then a miracle happened, and within the floodwater, these salt formations were formed. However, what you see is that when people already embrace a model, it's very difficult to untighten them from their model. Yeah, it's difficult. It's difficult, and at the other hand, if there is more research available, the more research comes available, the stronger this case will be built.
Right.
So I'm looking for people who are willing to do research on salt. And especially that's why I ask again and again, also the secular geologists, please do your work and start doing tests with ionic liquids. I need help there. I can't do this myself. And they have the tooling. They have to do this work. It's their work, not mine. I'm just a volunteer. I'm voluntarily helping geologists to do their work properly. And now they are all angry with me, but I'm just helping them.
And Stef, I've posted your article.
Yeah.
Your response to a specific critique. It's found at creation.com. Yes. I've posted it in the chat where you answer some of these criticisms put forth by, correct me if I'm wrong, his name is Kevin Nelstead.
Yeah. Kevin Nelstead.
Can you, and that's a really good article. We've touched on it in past discussions with you, but because we're always getting new subscribers, new supporters that are new to a lot of this, can you go over briefly what his criticisms are and why you find them to be rather underwhelming?
Oh, that's way back, long ago. I published that in 2013, if I'm right, on
yes,
creation.com. What were these questions? Well, one of the questions was what Henke brought in as well.
Right.
That they sample water from salt formations. They sample water within these salt formations, and they draw all kind of conclusions about the history of the salt formation. But I've explained to Kevin Nelstead as well what I did today to Henke. This water is not from the origin of the salt. This water has a history. It has a history. It has traveled far before it ended up in this salt formation. So you can't draw conclusions from those drops of water. Well, this is one of the examples. Right. I had many more questions from him, and I've addressed them all, and never heard from him again.
Actually, that was going to be my next question. Have you heard? Have you heard from him again, and have you seen a response to your response?
No, I haven't.
The answer is no. So, I highly recommend people check out that article. I've linked it in the description box as well as in the live chat right now. For people to check out. George, you were about to say something, brother?
I think Doki makes a good point here. Based on your request Steph to provide further research grant money into this sort of work. Doki says, EVOs are experts at wasting taxpayer money. Just ask Eugenie Scott.
Yeah.
And I always find, Steph, I'll give you an example. If you know about the Skull 1470 at the KBS Tough, they employed, I'm going by memory here, around, I think they undertook about 500, I think it was, dating tests using various dating methods, and none of them gave the answer they wanted. And what they did, and we put out a little video stream the other day about it, where they literally went to the half-life decay constants, and they literally picked one, and there's a big variance, by the way, in those decay constants. I don't know why they call them constants if they vary so much, but they picked a constant that would give them the date they wanted. This is how it works. They will deny, they will reject, and they will dismiss evidence unless it complies to their narrative. They will never accept it. I've been doing this for 11, 12 years now, and believe me, no one has ever accepted any, not even their own science papers. They won't accept them. That's my comment. But yeah, I think it's a waste getting that grant money, because we know what's going to happen.
Yeah.
George, I noticed you had a question here in the side chat too. Did you want to? I think now might be a good time to ask that one.
Oh yes, I forgot about that. I was the first one to put that up.
That's what I'm here for, brother.
Some old Earth proponents claim that the banded layers are deposits on curved ground over millions of years. So what have you got to say to that? They're effectively saying the ground was curved initially, and then the layers were deposited over that. It seems a bit silly to me, but obviously, if you look at the physics of that, that's impossible.
Yeah, it's. I don't know if. Look,
if you can get those couple of photos of those pictures where you showed the actual bends in all those different coloured layers, that would pretty much show that that's just impossible to do.
Yeah, I didn't share my screen, of course. Did I? Do I have to share my screen again?
No, I just put the screen back up for you, Steph, if you want.
Okay, so everybody can see my the picture now. Now, what you see in here is this is original. There has been a horizontal, quite straight layer, and then there suddenly are big bends in it. Well, I don't know. I don't know what happened, but I can't see this kind of bending have occurred because the ground under it was holding it up or so. No, I don't see. And there are other examples. What about this one? There's no way you can understand this from annual layers that have been bended. Then, because this one is then horizontal, then there was a whole lot of halide, sodium chloride, and then you have calcium sulfate. Well, it probably is calcium sulfate. And then this calcium sulfate layer it must have been a horizontal layer, because that's the theory of when it's delivered by water, then it has been a horizontal layer. And then suddenly it's been bended backwards all the way. And sorry, I can't make any sense of this.
Well, correct. Evaporites would, by definition, would occur in a horizontal position. They can't form like that.
Yeah, indeed. So this is a problem. This is definitely a problem for evaporation model. And however, from magmatic model, it's well, very common. It's what we expect from magmas, that the crystallization is very is not always very nice, because everywhere you have differences in pressures, you have differences in composition, you have differences in temperature. All these small differences make have an influence on the crystallization process, which can cause this kind of features.
There's a comment that comes in from Chris Peacock. I appreciate it, Chris. He says, when you have a plate pushing into another, it bends rock like plasticine.
Yeah, okay, that's the story. If you have a high temperature and a high pressure, then you can bend rocky material. However, the pressures and temperatures involved in that process are much deeper than this Castile formation, which is on top of, which has been deposited on top of all the others. So no, this won't help geologists.
Remember, Stef, when we did the oil exploration video, I looked at that particular scenario, and there are, well, I found 2 papers. There's probably more, but the 2 papers I cited looked at shale and at what temperature and pressure the shale would bend, and the findings of those studies were between 4.5 to 7 kilometers would produce the amount of heat and pressure required. And then, of course, you'd have to have the horizontal displacement to make them bend. So there's a lot of pressure and heat involved in doing that. And, of course, because we find the oil at 2 kilometers depth, I think I said there needs to be at least 5 kilometers of erosion for that to occur. And if you compare the age that they say oil would take oil to form, and using their erosion rates, it just doesn't add up.
No,
it doesn't add up.
No.
Stef, as we start winding it down here, can you go back a couple slides to where you had all of this back and forth with Kevin Hankey documented, and where people can just for anybody new in the chat as well, since we do these live, we oftentimes get people coming in kind of near the end. So for anybody interested, this back and forth between us and
you mean this
Kevin Hankey. No, you had it on screen just a couple minutes ago before you had the series of responses all.
Oh, okay, that's in the beginning, at the start of my presentation.
There we go. Yeah, right. Yeah.
Oh, that's it. Yeah.
You got it. So for anybody, especially new to this channel, I highly recommend, going through the entire series and just see how the arguments are being dealt with. And I think a lack of real responses from the old Earth side. But as you can see on the slide, Dr. Hankey, he thought he had a strong case to disprove YEC. This was back in July. And then we did a show. I've actually got it up on the website under the geology section with Stef, where Stef addressed the Castile formation. And then they more so recently put out 2 response videos, I think can be found on Gutsy Gibbons' channel. And then what this is a response to those response videos. So yeah, I wanted to give everybody a rundown of what's been going on and why it's important. So that's it for questions, which means Stef and George, why don't we have some final words, final points, final thoughts from you brothers, and then I think we'll kind of wrap it up.
Yeah, well, I've not very much to say anymore. It's as clear as this: anhydrite cannot be formed from water. It's just not possible. So all these hydrothermal ideas by which young Earth creationists have about anhydrite. That will not work. There's an origin from the ocean. That's an idea from the secular geologist. Sorry, it won't work. Anhydrite cannot be formed by water. It's as simple as that.
I appreciate that, Steph. Great presentation today. It's an important one to rewatch in order to just kind of get all the information and data that you presented to us. George, thanks for being here as co-host. Any final words, final thoughts from you there, brother?
I think Steph pretty much wrapped it up, but I've got a little message I want to sort of forward to people in the chat. It's just titled "Pick Up in the Rain." One night at 11:30 p.m., an older African-American woman was standing on the side of an Alabama highway trying to endure a lashing rainstorm. Her car had broken down and she desperately needed a ride. Soaking wet, she decided to flag down the next car. A young white man stopped to help her. Generally unheard of in those conflict-filled 1960s days, of course. The man took her to safety, helped her get assistance and put her into a taxi cab. She seemed to be in a big hurry. She wrote down his address, thanked him and drove away. 7 days went by and a knock came on the man's door. To his surprise, a giant console TV, color TV by the way, was delivered to his home. A special note was attached. Now keep in mind, color TVs back in those days were very expensive, right? And this is what the note said. It read, "Thank you so much for assisting me on the highway the other night. The rain drenched not only my clothes, but my spirits. Then you came along. Because of you, I was able to make it to my dying husband's bedside just before he passed away. God bless you for helping me and unselfishly serving others. Get a load of this. Sincerely, Mrs. Nat King Cole." A great message.
Whoa.
Powerful story, George. Powerful story, and a beautiful, strong way to end the stream, end the show. Again, George, thank you for that, brother. And Steph, again, I know how busy you are, and I don't know how you find time to sleep, but you are a blessing, and I want to thank you for defending the faith, and also thank you for blessing us with this important information and giving us your time for this important show. So, Steph, George, God
Thanks,
bless
Steph.
you both.
Yeah. Thank
God
you.
bless you.
Thank
My
you,
pleasure.
guys.
My
Wow.
pleasure. God bless you both. God bless everybody in the audience. Thank you for the support, the super stickers, super chats. And we will see you again tomorrow night at 8 o'clock. We've got a debate on human evolution. So we will see you then. Standing for Truth is out.